Welcome everyone. Today is Sunday. Now is 2 o'clock in Hong Kong time and Taiwan time. So this is the second talk for our show in National Taiwan Museum of Fine Arts, Æthereal. This talk is on AI and music technology because our show Æthereal in the museum is actually about how different systems affect our daily lives. So we have three artists in the show, three groups of artists in the show, Kiriko, Mark Chung, and Remy and Kivanç as our third group of artists. We had our talk last week on how artists resituate their daily lives in the museum space. So this week we gotta concentrate our focus in the on the third group of artists, Kivanç and Remy. Their work, Gestalt #1, and also new notation is part of the show, where very computing orientated kind of work. So we can start with Remy. Remy is trained as a composer and also a new media artist who is now based in Vancouver. He is the founder of Sunset Studio, which is a new gaming studio that he set up for the next couple of years to do a new game. So Remy, can we start from you? So today's format is gonna be we have two artists and two researchers. Each of them, we're gonna present their interests for a couple of minutes, and then we go into our discussion panel to talk about what we are interested in, how we think about AIs in different ways, because our artists are using AI as a creative means to do their artwork, and our researcher is actually basically doing very practical research on the practicality and how AI gonna push push music and how AI understand music in general. So can I start with Remy?
Yeah, I think Kivanç just lost connection. He'll be back. I'm sure of it.
Okay. Yeah.
Here is start streaming this. Can you see this?
Yes, we're waiting.
Yeah, here we go. Starting a little timer. So yeah, my name is Remy Siu. I'm a Vancouver-based new media artist and composer. I should say quickly that Vancouver is on the unceded territories of the Squamish, Musqueam, and Tsleil-Waututh First Nations. And that is particularly important to acknowledge right now, especially as we have Canada Day. We just had Canada Day, sorry. Kivanç says he needs to be let back in. So whoever's letting people in, Kivanç needs to be let back in. Yes, so my practice these days revolves around the use of digital game mechanics as a compositional tool and the use of algorithm. I don't make traditional scores anymore. And I would say scores in the musical kind. I make kind of these hardware, software apparatuses that often manifest on stage that I consider to be scores for performers to interact with and kind of bump up against. But really, if I were to boil it down very simply, it was just following a line of practice that started with it asking myself, when I was still writing more music, what if I created scores that were not delivered on fixed media, but in some form of mutable delivery system. So, and I think that, has a lot of consequences that we actually really haven't looked at and played out at all. Sorry, I mean, not at all, but there's a lot of space there to explore. So I will go into some of these examples here. When I say real-time game mechanics, I mean kind of real-time digital game mechanics. And my approach is very much informed by my experience in theater, kind of devised theater as well, and experimental performing arts. So there's a series of works that I did called Foxconn Frequency, which involved these real-time systems at play. Just going to start watch this video here while I'm talking, where instructions are being given to the performer in real time, and they are receiving input from the performer, and the system itself is reacting to the performer's input. In this case, it takes place as a kind of a digital game on stage, where the performer has to perform specific kinds of piano exercises, and they can fail or succeed under certain kind of constraints. But if they fail, they have to repeat that exercise over and over again. And part of this is kind of getting to a point where that what we see in performance a lot and what we think of as liveness is actually really revolved around certain kinds of stakes and presence that the performer has. And so often it's very difficult for performers to be extremely present in space if they already know what they're doing, or if they're thinking about what they're doing before they're doing it. So really, some of the software that I'm using, some of these systems that I build are all about trying to remove that cognitive load from the performer so they can be wholly present and be reacting and problem solving in real time in front of the audience, which I think creates a very interesting effect and tension and stakes and a reason for a show to be live as opposed to, say, recorded or a fixed medium, right? It's not a reproduction of a fixed thing. So that has kind of extended to this piece that is in the gallery right now, which is called New Notations for Multiplayer, where it's kind of a mix of, I suppose, the crafting of digital game mechanics and instrument making, or software instrument making, where the rhythm and what can be achieved by the player, and I mean by the rhythm of sound, the timbres of sound, and what happens is entirely determined by the kinds of mechanics that I am employing in the work. It really is an exercise, it seems to me, in composition as the act of creating policy for virtual space, and not so much no longer working in specifically, I guess traditionally in Western music, which is notes and pitches and what have you, right? So chords. So here it's about, for me, how can I provide a tool set or a set of rules that I can give to performers and that they can realize, but wholly that it has a kind of interiority in the sense that these rules define the work, right? Also, kind of separately, this work, as I was kind of doing more and more of these things, I wanted what was being shown to the audience visually also to be essential to the player to operate. So what we are seeing here in the sense of audiovisual work, the visuals I wanted to also serve as a kind of interface, and a very much a required interface by the performer, as well as something the audience can see and watch. So this work is also for multiplayer. In this video, you can't really see, well, if I skip ahead here, maybe we can get to a short multiplayer area. Yes, here. So what we see here is the depiction of another player inside the virtual space that one player is in, which is these kind of like blue lines here, where the points that they have selected. And so you share the same space with another player in this area. So if you enter the same space, that also affects the other players. So if you're playing with 4 people, you can intervene on other people's space. And so part of this piece is really about the 4 people who are playing it, mediating that space together and trying to make music, and or maybe not, maybe just being chaotic in that space. There's really no rules in that regard for this work. So that would extend, I would say, over to, I don't have any pictures of the Gestalt generation here, but except for this older picture, which is no longer applicable. But the work that's currently in the Taiwan Gallery involves two of these robot arms, two kind of separate AI entities learning to live in a very small space together. And part of this is also very similar to some of the interests that I had in performance, where I wanted to see two performers be kind of problem solving and learning and present on stage. I think that has a particular kind of effect. And in this case, in this work, what we do have is two robot arms, or these two, I should just say, entities. They are learning in real time throughout the period of the gallery. And so my hope is also to expose the failure in this process, as well as all these things that we may miss and throw away, and expose that a bit. So I ran out of time already, so I already went quite quickly, so I'm going to pass it on to the next person.
Thank you, Remy.
Yeah.
So Kivanç Tatar is the second half of who made the Gestalt generation #1. So Kivanç is the sorry, just interactive AI. He's gonna be the interactive AI associate professor in Stockholm, right? Kivanç, right? So Kivanç's interest is more on creative AI and how AI technology can be applicable to creative outputs. So Kivanç? Here. We can't hear him. Hold on a sec. Kivanç? Oh, it's dropped out again. So, well,
I think he's having some connection issues.
Yeah, I'll just ask questions to Remy for now.
Mm-hmm.
How do you see, if you continue your work, how do you see audience and, Kivanç?
Can you hear me now? Hello.
Yeah, good.
Sorry about that. Firefox didn't like Google Meet, and then Chrome didn't like my microphone, so it has been like a normal, new media chaos situation. Yeah, I'm back. I'm back in business stuff.
Yeah, okay, good.
Let's roll.
Good.
So I'm going to choose my PowerPoint again. I hope you can see it. Can you?
Yeah.
Yes.
Awesome. So hi everyone. I'm currently a freelance artist, but I'm going to start my assistant professorship at Chalmers University in October, which is in Göteborg, Sweden. I'm really excited about it. I'm also going to be affiliated with the Fine Arts Department at University of Göteborg. These days, you just end up doing everything in a professorship. And I'm really excited because it's interdisciplinary. And my interdisciplinary research is about using machine learning and artificial intelligence for artistic applications. I'm actually a musician. I'm coming from I would say I have a musician mindset, but through time, my practice has expanded to a bunch of different areas, including visual arts, moving images, 3D, a little bit of dance lately as well. In terms of research practice, I really like being interdisciplinary. I like to combine art and technology in that sense. As I mentioned, I cover quite a lot of artistic disciplines, and on the technology side, I also cover these very specific ML and AI areas, such as multi-agent systems. I'm an expert in multi-agent system. I'm an expert in what's called statistical sequence modeling, which is related to text generation and all that stuff, but it's also very important in some type of music generation. I'm also, I had some experiences in clustering sort of algorithm, and I really like supervised machine learning algorithms. I also did things with like virtual reality and all that. So there's like technology on one side, arts in the other side, but in the middle, I also, of course, naturally, I interact with human-computer interaction. I really like effective computing. I did a little bit of research on effective computing in sound, and also, of course, naturally, I'm involved in design aspect of all these things. In terms of my research perspective in machine learning and AI, I'm a little bit taking a stance different than the conventional ML and AI in the sense that I'm not really trying to optimize anything, right? I'm not trying to optimize such as like the electric consumption of a fridge or an electric consumption of a car. In arts, we are not literally making anything better or worse, right? You can't really say if a composition is better or not, but you're involved in a design, iterative design process that's ending up as an artistic product, but sometimes, like in Gestalt generation no one, the artwork itself is that design process. So there's a little bit of difference from machine learning and AI. And since I'm limited with time, I'm not going to go into the details of my research practice, but I want to give specifically the understanding of how I stretch myself within using ML and AI for musical applications. That sense, I'm really interested in audio-based musical applications, and I'm specifically focused on approaches using discrete latent audio space and continuous latent audio space. And of course, starting from music, I'm kind of like involved in different parts of artistic applications because I think dissemination is also really important. I mean, we always make these like systems, you know, being used in musical creativity, but then I think it's also important to put these systems in an artwork and present them in known festivals. As I said, I'm looking at musical audio generation from a different perspective that's called multi-agent systems, because I think multi-agent systems are beneficial for such things because they think there are different agents interacting with each other, and that's how things happen. Like internet, you know, my computer right now communicates with your computer, and that's how we have this communication happening right now, because they talk to each other. And if you think about it on stage, you know, a bass player talks with the drummer in a musical way, not in like a communication way, but in a musical way. They understand their beat, they understand their harmony, and they interact with each other to make music happen. So in that sense, I see similarities between multi-agent systems and musical performance. And in that sense, like I went deep during my PhD, I went deep in this area, and I like did a survey in systems using sort of AI and ML, and then a bigger picture in autonomous systems for musical applications to end up with a taxonomy of musical agents. And you know, at the end of this, my question was, okay, what is interactivity then? And from the perspective of systems, we end up with 6 types of interactivity. I'm not going to go into the details of this, but like this was more of a sort of like an understanding of how the autonomous systems are used in musical applications. When I say autonomous systems, it's almost like a bigger area than the AI and ML, kind of like thinking of all autonomous approaches for musical generation. And then after that, of course, there's the design involved in this, but I'm not going to go into the details of that. But I want to focus on my musical perspective. I'm really inspired. I really like this idea of organized sound that's proposed by an electroacoustic music composer called Edgar Quares. And he says, I decided to call my music organized sound, and myself, not a musician, but a worker in rhythms, frequencies, and intensities. So during my PhD, I ended up thinking about, okay, if music is nothing but organized sound, then what kind of organizations are involved in this process? And I came up with 2 types of organizations. Organization in audio space, so that we can differentiate one audio from another, and organization in time, so that we can compose musical sequences. So in that sense, then it was easier to go into the machine learning and AI approaches to find ways to teach the machine how to come up with these types of organizations. And for that, you know, I ended up with two different lines of research. One's focusing on discrete latent audio space, and the other one's focusing on continuous latent audio space. In terms of discrete latent audio space, I ended up with the system called musical agents based on self-organizing maps. It's ideally, again, this idea where the organization in sound memory happens by using self-organized maps, which is an unsupervised learning algorithm for clustering. And then for the organization in time, I'm using algorithms that are classified as statistical sequence modeling algorithms, they are called. Anyhow, so there are like future research that's related to this, but I'm not going to cover these. And of course, using this approach, we did a bunch of musical performances. Some of those involved playing live with the system. And it was really fun. But before I finish my introduction, I also want to talk about the continuous latent audio space work that I have done, which is latent timbre synthesis. And this is a little bit different than the discrete latent audio space, because I wanted to have a continuous abstract space, which is creating a timbre space where similar timbres are closer to each other. And here what I'm generating using a deep learning algorithm is one audio frame. It's very short. It's almost like 10 milliseconds. But what was really interested in this, that the algorithm is trying to take these like very short sounds and trying to create a space of them. But what we see here, each of these sort of lines, sort of things, these squiggles, are actually coming from the same audio file, even though we didn't tell that to the algorithm. And each line is actually not a line. It's made up by these circles, and each circle is an audio frame. So what we see here on the left is a latent audio space made out of audio frames, and each sort of line, sort of squiggle thing is a sonic gesture within an audio recording. And on the right, when we make such a space, it's really interesting for musical applications, because on the right what we see is we have the blue one, which is from the dataset, and we have the red one, which is also from dataset, but the green one is generated by interpolating in the latent timbre space. And it becomes this like new synthesis algorithm where we can find timbres between two different timbres. For example, let's say you have a piano sound and then you have a sound of a glass shattering. What would be a sound in between those? So it's kind of like enabling us to find new sounds and use them in musical ways. And this is a new work. This has been published in 2020 and still continuing. And I'm interested in combining this with different interaction possibilities using, for example, virtual reality, using different interfaces, and continuing on this. And another way that we interacted with this algorithm was focusing on movement computation. And then we made the system called raw music from free movements. And this is a work that I've done with Daniel Bissek, fantastic researcher, Marie Curie research fellow. And here we combined a deep learning algorithm that's encoding movement sequences to a latent space. And from that latent space, we are combining that latent space with a latent space of audio to generate raw audio at the end. So the input is a movement and the output is a raw audio. And this is very new, like fresh out of oven. It's going to be published end of this month. Please stay in tune. And it's going to be published at the AI Music Creativity Conference. There's all sorts of things I could talk about around these, but this was more like a summary of my research, and it was a little bit fast, and I'm happy to answer any questions if you have. And thanks for following me in a fast pace.
Thank you, Kivanç. That two paper is very interesting in terms of creating new music and in terms of new timbre, and also deriving music from new movement, which is very important and actually very frequently seen in a lot of the contemporary art sense of work. So our next speaker is Yang Yishen. He is the Associate Research Fellow Professor from Academia Sinica Institute of Information Science, also the head musician of Taiwan AI Labs. So, Yishen?
Okay. Hello, everyone. Can you hear me?
Yeah.
Yes.
Hi, my name is Yishan Yang. I live in Taipei, and I am a father of 2 daughters who can wake up anytime from now and interrupt the meeting. So I'm sorry for that in advance. And it's my pleasure to be here to talk with you. I've been working on developing machine learning models for music since about 15 years ago, but I started to work on automatic music generation only until about 5 years ago. And because I'm not a musician myself, my research on automatic music generation is much more motivated from a machine learning researcher or a computer scientist point of view, rather than from a musician point of view. So I'm interested in creating fully autonomous AI that can generate music without any human editing, post-processing, or any involvement. And we find that the performance of existing models published at academic venues are simply not good enough till now, and with plenty of room for improvement. Although there are impressive demos from the industry, it is hard to tell how much of human editing was involved to create such music pieces. I think it is true that for a musician, a fully automatic music generation AI may not be needed, because the musician can interact with AI to create music together. But we are simply interested in improving the capability of AIs for creating music in an autonomous way. So far, my research has been mainly concerned with building autonomous AI for generating piano performances and singing voices. Okay, for piano music, we want our AI to learn to not only compose musical scores, but also to play the piano composition expressively like a human pianist. To learn to play the piano expressively, our AI actually learned from audio recordings of piano playing we downloaded from the internet, like from online platforms like the YouTube. Given audio recording, we apply music understanding technology to get access to information regarding what and how has been played in the recording. And then based upon this understanding, we train our AI models to mimic human behavior. More specifically, we hope our AI can learn on its own the dependency among musical events without much human-imposed rules, or without any human-imposed rules. We expect that the model can learn something universal regarding the music instead of simply copying existing pieces. Moreover, because we do not impose any rules or restrictions, the AI model has great flexibility learning what it believes to best explain the music data we give to it. But so far, we have proposed many solutions to improve the performance of our AI. We believe the AI is getting better and better over time at creating original piano performances, but it is still far behind professional human musicians. Okay, and we have also been working on a singing voice generation project that we expect our AI to sing autonomously without human-specified lyrics and melody. In other words, it is not just a singing voice synthesizer, but it has to decide the lyrics and melody on its own, like improvisation, while generating the singing voice. Similarly, our AI learns from audio recordings of singing performances. We find this task to be even more challenging than generating piano music, because the vocal sound has much more diversity in the timbre than the piano sounds. However, I think we are making good progress so far. Okay, I think this pretty much summarizes my research. I realized that I have been working too much within myself, within my group only, and maybe our technology is getting mature and we are getting closer to start collaboration with musicians to see how our AI can create music together with musicians. Therefore, I'd love to get to know you better, and maybe we can start some conversations about possible collaborations. That's all. Thanks.
Thank you. This is exactly why I bring these two groups of people together. So on one side, we have the artists who actually create works, and on the other side, we have engineers and researchers on this very promising AI frontier on actually how to. And actually, I'm going to ask these questions later, but AI, in my point of view, is actually the way to understand how human mind works in terms of creativity. AI is basically mimicking in a lot of ways that how or training how human creativity works and how human brain works. So our last speaker is Su Ning, also Associate Research Fellow and Professor from Academia Sinica Institute of Information Science. Su Ning.
Hello.
Hi.
So, okay, so first, Andrew, thank you very much for inviting me here. And today I would like to show some of our research results in our labs. Okay, so first I am Remy Siu from Institute of Information Science, Academia Sinica. And our lab started from 2017, and we focus on a lot of music information retrieval or MIR research. And in recent year, we focus on the building an ecosystem facilitating bidirectional transfer of technology or knowledge between computer scientists and musicians. And in the past few years, we have done a lot of projects. And in this very short introduction of our research result, I would like to focus on two directions. The first one being a human-computer duet system for virtual musician performance, which is about our system on how to generate a virtual musician's body movement directly from music signals. And the other part is more related to computational musicology research, and it is for revitalization of our cultural heritages. And the technique it used is more like automated music transcription or recognition. So as a research-oriented and technology-oriented group, we focus on develop new technology for some technical applications. So as AI researchers, the most important thing is that we need to have a lot of data with rich annotation, which can provide the information of music. And the data will include not only audio, but also we are also interested in like symbolic one and score ones, and even video, and even something like motion capture or body sensors and others. So all kind of data which are related to music activities are of our interest. And for the application part, yes, we focus on deep learning based method, and the application is for either music recognition and generation or interaction. So in this figure, we show some of our research results, like a neural network for automatic music transcription, and its test is quite similar to Professor Yang just mentioned. The music understanding technology. Yeah, it's like to convert music signals into like MIDI signals or score level informations. And this one is a so-called harmony transformer, which is one work done in 2019, and it won the Best Paper Award in the International Society of Music Information Retrieval Conference. And this work is represent the first one to use the transformer network to do automatic recognition of musical harmony. And for the collaboration part, we hope we can collaborate with music producers and musicians or musicologists, and not only human musicians, but also virtual musicians. So in this part, we consider not only how to create virtual musicians, but also how to let a human play music with virtual musicians. So So in our first project, the human-computer duet system, we have this here is our one of our example. I think I need to play this first in order to for your better understanding of what we have done. So so in this video, we have our ground troops musicians. They are humans and they play the music, and we want to automatically generate the body movement from the music itself. Yeah. So below is our result. So this skeleton here and this animation here, their body movement resemble this human quite a lot. Yeah, but actually they are not the same. And the reason is that such kind of movement are automatically generated by the music signal itself. Yeah, so this is like we can automatically generate the virtual musicians, or also such like recent very famous VTubers, and for them to have a automatic performance, and we as the directors, we just need to provide the music, and the music as the input, and the output can be the full performance. So this is the first idea we have done. And if we have such kind of automatic body movement generation technology, and together with the real-time music tracking technology, we can let like in this example, so our human musician can play music with the virtual musician, and everything about this virtual musician are automatically generated, including that this virtual musician need to follow human musician's speed automatically. Okay, so this is our first part of our research. And the second part of our research, this is actually not that related to music generation or creation. It is actually another aspect on how to analyze the music that we human already created. So so this is more related to computational musicology. So so we create corpus with digitized semantic annotations with automatic transcription and recognition. And here are some of our results, including Taiwanese Aboriginal music, and also known as Pazibubu of the Bunong tribe. And this result is very interesting. It is about our research on Chinese guqin music. And here, it's like that we are analyzing one guqin performance. And we use the pitch tracking algorithm to track the onset time and also the pitch contour. So in this performance, we can observe the vibrato patterns of each note. Yeah, and we found a very interesting relationship, like the vibrato behavior of the guqin performance is highly related to the tonal structure of the music. And such kind of phenomenon is less observed in Western music, but they are quite common in like East Asia music. Yeah, so with such kind of music recognition technology, yeah, we can find some interesting musicological knowledge. Yeah, so this is this is just very brief introduction of the research result of our lab. Thank you.
Thank you, Suli. Thank you for all of the speakers. Let me do some summary and also what I think about the other two research. Suni's research, the second research is very interesting. I think there's also another application in linguistics, especially tonal language. because your pitch tracking thing is very. I have seen them in papers in terms of linguistics and also in tracking, especially because we are basically Chinese speakers, and we are actually one of the few very interesting tonal speakers in East Asia. So I think this is also a way to track and also compare. When also that goes into Yang Yixuan's automated generation in terms of the lyrics and in terms of the vocalization of words. The very difficult part of actually writing lyrics for Chinese speakers is actually the tonal part, right? So I mean Taiwan people will understand, and also I'm from Hong Kong, so we do Cantonese speaking. So we have difficulties in terms of writing lyrics in Cantonese songs because the tonal structures of the language itself is very strange and not linear in a way. And also it's very expressive, and also it related directly to music itself. So can I throw a couple of questions to the two researchers from Taiwan first? I would like to understand what kind of, what in your research, what is your how is your understanding of audiences? Because I think for creative industry, for creative works, it's very important to actually understand the idea of audience. So from Yang Yixuan and also Suni's research, you produce a lot of materials, but what kind of audience are you looking for, and how is your expected audience read your material in a quantitative way? Soli first, maybe.
Okay, so oftentimes
who will be first?
Suli first, please. Thank you.
Okay. So yes. So first, thank you for your questions. So actually, as researchers, your question is very important. Yeah, actually, in our research process in the past few years, when we are developing our technique, we ask ourselves, and also we are often asked these questions, and I have to say, I don't have a clear answer right now. Yeah, but in the past few years, we have held a number of musical concerts. Yeah, some concerts held by ourselves, and some collaborate with other school. For example, we collaborate with an AI concert in NTHU. Which is Tsinghua AI 乐团, and every year so we have hundreds of students who are interested in AI music will join. Yeah, so to answer your question, my first answer is that we can find in recent years more and more not only students but also other people who are just interested in how about combining music and AI. Yeah, so just these keywords could interest many people. Yeah. So this is the first one we can find, and the second one I would like to mention our virtual musician project. Yeah, actually, this project is somehow it is actually not launched by myself. Yeah, it is actually built by other mostly my student. Because they like I mean they like VTubers. Yeah, so so for me, I think I am too old, yeah, to enjoy VTuber programs. Yeah, so but but I'm very sure that my student, most of them a student in background in computer science or double E, most of them are fans of VTuber, and it is really hot now. Yeah, so more and more people want to do this, and our program, our concert get more and more popular. Yeah, so to mention this, I would like to point out another feature about the music related creativity activities will be it will be combined with the other kind of entertainment recreational content, yeah, like animation. Yeah, I think animation is very important, yeah, part, yeah, for to get the audience. Yeah, yeah. Once you can have animation, and it is automatically generated. Yeah, and it contains some element, yeah, which can interact with the audience. Yeah, that would be quite interesting.
Yeah. Thank you. Yang Yishan has anything to talk about?
Okay, I think there are at least two groups of target users of an AI music technology. One is musicians or composers. The other is the general public. And for composers, maybe we can build an assistive composing tool to help composers make music. But as I said, my research has been focusing on autonomous model for fully automatic generating music. So we do not explore much in that space. And the other type of users is the general public, right? So when we talk about interacting with the users, there are at least two ways. The first is to release a musical, an album or a song created by AI. Okay, and the other is an interactive tool that interacts with people. It's like something like an AI musician in your pocket that it can interact with you, right? So if it is about releasing like an album of music, then it's about the quality of music. And typically we rely on our ears. And we also have an in-house musician working with us who can work as our judge for the music, okay? But we care more about the interactive side, because if it is not interactive, then people, I mean, the general public cannot tell whether the music is made by human or AI, right? We already have tons of good music produced by musicians. So why do we need an AI to produce music, right? So the strength of AI is in this interaction, real-time interaction. So the AI can interact with people, it never get tired, and because of the randomness mechanism, it can generate something new all the time, although the quality may not be as good as professional music creations, right? So speaking of creating interactive tools for human beings, I mean, we are still exploring. This is quite difficult because we don't really know what the people need, right? We don't need what kind of it's about experiences, right? So we need to keep exploring. Maybe we need to have some art installations. We need to work together with musicians, artists, and to see which kind of interactions or experiences people would find useful or interesting. And then, we keep starting from there, we keep improving. And I have to be honest, we still know little about that.
Thank you. Thank you. So maybe I ask Kivanç, what do you think about this kind of automated music composing as opposed to your research in actually movement inducing music?
That's one paper that I've also worked with raw music generation, raw audio generation in terms of music generation. Going back to your question about who is the audience, or like what is the interaction with the audience, I mean, that is a bigger question of the contemporary arts, right? Who's the audience of the contemporary arts? And that is very specific to which specific artistic style you are looking for. So in that sense, I think the question is really dependent on the particular artistic application. So if we are talking about, for example, music generation for YouTube, background music generation for YouTube, that's a different kind of audience, and that's a different kind of like interaction with the music, with the audience. But if we are talking about, for example, but if we are talking about, for example, a Spotify music album through a virtual artist, that's a different kind of interaction. So in my opinion, we really need to get deeper into these machine learning and AI terms, and then pass beyond them and go into the specifics of each application that we are talking about. So in that sense, the question of what is the audience of ML and AI musical application is almost like related to the question of what's the audience of a musical application.
No, because why I'm asking this is because not only contemporary art, but also since modern art, the understanding, the idea of an audience, not who or what they are, but an audience is important. But a lot of the work in musical generation is they're not seeking for audience, rather than they have provide like you said, like a background music for computer game or whatever that is, like building spaces, is like MuTech, right? It's like, MuTech, right? MuTech is like the elevator music of the 60s, 70s, and 80s. So like I'm kind of lost in a way in when I look at this kind of music. I don't know. What do you think, Remy? I think Remy has something to say.
Sorry, I think you said that. No, I just wanted to say. I think you meant André Muzak, is it not? The Muzak. Yes, yeah.
Yes. Yeah, not the festival.
Yeah, the festival Muzak. Yeah.
No, Muzak. So. Yeah.
Yeah. Sorry, I guess the question.
No, as a composer, how will you think when you write compared to this kind of computational generated music? Because what your work, your new notation work is actually rethinking how, new music has been always rethinking how music is being written. And your new notation work especially is how the performer is also part of the composer also, but you as a composer make a framework on how your sound is going to be projected as a work. So that's how you define you as a composer.
Yeah. I think it's interesting because, when kind of having encountered, I guess I was lucky in the sense that, in my education and in the various places or in the place that I studied, I guess, I had been exposed to lots of music generation, either through kind of state machines or either through, in this case, like AI. And it probably planted a seed very early on when I was in my undergrad in composition, thinking about as in, many people may eventually think about and have thought about it. It's like, well, if, for example, my end goal is the creation of a specific series of sound events, just thinking specifically about sound, then yes, this is a domain in which these tools will be helpful to me maybe in the future, and or also that they could replace me to a certain extent. Obviously, I'm not really afraid of that. I was interested in the idea of it replacing me, but then also moving to an artistic space where it was more and more difficult for these tools to be useful to me, and to a certain extent where these things could these specific approaches could say, quote unquote, replace me. I say that in the sense that redefining compositional practice in my mind as something that's non-colloquial or that doesn't specifically mean sound events, but the definition of actions of the performer based on lots of relationships between rule sets. And also something that's difficult in engaging people who perform the work in a lot of ways in their whole selves, as opposed to, say, just their approach to them as an entity that interfaces with an instrument that creates sound. That was something that I, am interested in. Like there is all of this kind of like area where that's why earlier I was saying that I had abandoned notation in this regard, right? For something that is a little bit more anyways, that could go for a long
piggyback on Yang Yishen on how on what kind of rule set is going on in his AI generated music, because also Suli's work, and like I'm interested on what kind of rule set and how does it compare to, like you said, your like the musical generated, like the generated music in new music scene, or even basic things like scatting in jazz kind of things. So I'm very interested in listening to what Yang Yishen is gonna say.
I don't get your question quite clearly. So
what kind of like how does your what kind of music how does your your automated generated music what kind of musicologist kind of sense of what kind of rule sets does it follow? Like does it follow a jazz kind of type of understanding of music, or classical understanding of music, or even musician folk understanding of music, or it doesn't matter at all?
I see.
You need some kind of input
I see.
to become.
We start with pop piano music. So the genre is mainly pop, but the same methodology can be applied to jazz or classical music as well, as long as we change the input data. Okay. And but so far, I think the problem of the AI model is that typically it learns to average everything, right? So a critical problem of the performance, the generated piece of current AI models is that they are not unique, right? It's not special at all. It's about the average of all the music pieces out there. And also it doesn't have a sense of structure. So it doesn't, it doesn't involve its structure over time. You cannot sense like a verse, chorus structure in the fully automatically generated music. And
so
it's very it doesn't have an idea of motif or the musical theme. So that is something we are currently addressing. We want to build a model that can take, for example, a short sequence of melody note, and then expand and then developed the melody sequence into a full piece of music in the style of pop.
Okay, so basically,
so we would not use any wood.
Okay, so it's stylistically mimicking something, but doesn't understand the underlying melodic motifs that you were saying.
The strength. I mean, the current the state of the art models do not have an idea of motif in music. So that's something we want to improve upon. So that's something we're developing.
Of course, Kivanç, you want to say something?
Yes. So what Professor Yang was mentioning was the long-term structure, and that's one of the the current research how to say challenges in the area that we also have in my area, which is raw audio generation, raw musical audio generation. Like it's people achieve to generate, for example, a second of audio or 5 seconds, 10 seconds of audio, but it's really hard to generate, let's say, 15 minutes, or 20 minutes, or an hour of music that is stylistically consistent, where at the minute 50 you go back to the minute 5 and there's like a quotation from there. So it's kind of, that's one of the challenges right now. What I want to go back to is in the beginning of the conversation where we talk about AI, replacing the composer or some kind of taking actions and things are changing. So there, I really want to focus on the first emphasis that I want to make, which I'm seeing that in almost all the talks that's being missed, is that these algorithms are made by humans, right? It's made by people like me or any other person here who's talking. in that sense, our understanding of music is embedded in this algorithm. The way that my algorithm works is different than the three people talking here and in their algorithm. For example, I am really focused on this idea that raw music generation using decoupled way of where there's an organization of sound in latent space and there's organization in time using that latent space. So that's a very specific way that's coming from electroacoustic music theory, but it's not the same as someone who's coming from, let's say, a jazz pianist, right? The jazz pianist's understanding of music is completely different. Although I could say, like, you can sort of say they have quite a lot of similarities, but in the algorithm, it changes everything. So we should really be, I think we should put an emphasis on that each AI algorithm is made by a human being or a group of people, that their understanding of music is embedded in there. So they have choices that fundamentally affects the output of that algorithm. That's the first thing. Second thing is, we always think these algorithms as like these magical boxes. That's like amazing. You just like take it, install it, press a button, fantastic music coming out. That's never the case. I've been working with them since maybe like 2014, 2013. And then Remy just joined like recently in the last 6 months in this just short generation. And it's hell of a process. It's a nightmare to start with. You generate maybe hundreds and maybe thousands of things. You do like iterations on the system, architecture, maybe like over the years or such long times to generate those like maybe couple of viable examples that is actually has good quality enough to publish or present or expose. So we should start talking about how we interact these algorithms. So Remy is never going to be replaced by this algorithm, but his working structure is going to change. He will be working with curation of datasets. He will be, gathering a bunch of examples to train this algorithm that he thinks it's a good one because he tried all different algorithms. As if, you are trying different synthesizers and you're like, oh, I like this FM synthesizer, but I don't like this, like subtractive synthesizer thingy. So as if you are choosing different VSTs, synthesizers, you will be choosing different AI algorithms because you like one than the other. And then you will be working with the datasets. You will be working with the creation of datasets. In the interaction, you will be generating a bunch of examples, going through all those examples, and then choosing the ones that fits your aesthetics and the aesthetics of the artworks. So in that sense, I don't think composers will be replaced, but their work structure, their framework will be perhaps changed.
I'll say some composers will be replaced, but that's fine. It's like, whatever. I think what's interesting is even hearing the talks by everybody here, the thing that I'm just thinking about is like, how can I go in and break it? How can I break this? Like, how can I take a look at the process and try and do something wrong in just the right place to make something very strange, or to make something kind of maybe that's missing, only because we have different goals, right? That's what you were saying, André, right? Like I was thinking about even looking at the kind of automated skeleton kind of animation that is created based on, I guess, the analysis of an incoming sound file. And I'm thinking about what kind of music do I have to write to make this skeleton do some really messed up things, right? Like as a way of like, pushing back against, not pushing back as much as like interacting in mischievous ways with these pre-existing kind of processes and systems. I really see that as like doing, certain extent, one of the jobs of an artist, or one of the approaches of an artist on that scale, and even on a larger scale, and on a macro scale of, say, like in institutions and systems and larger systems, and even like how do we go in and break it just in the right way to make something very new.
Yeah, well, you always have a hacker kind of mindset in terms of how you deal with systems. So it's kind of fun to listen to you. So anything else anyone want to add to the conversation? If not, we can end it here. Yeah, yes. Okay, thank you very much for joining us for this discussion. Thank you all the speakers, Remy, Kivanç, Yang Yichen, and Suli. Thank you for coming.
Thank you.
Let's keep in touch. I think we should keep in touch. This is a very, very interesting conversation between creatives and also engineers, which is always fascinating how, as a curator, I would love to put these people together to just to shake everything up and see how messy it can become. This is my goal to do this. Thank you so much for having us. Thank you for the museum for having us. Thank you.
Thank you.
Thank you. Thank you.